Hello everybody. Today we're going to be going over the Lewis dot structure for nitrate. So the first step in drawing a Lewis dot structure is to count the number of valence electrons. So nitrogen has 5 valence electrons. Let's switch to white. So 5 valence electrons, and then we're going to add 3 of the oxygen's 6 valence electrons. And then we're going to add an additional electron because of this negative charge. Because we're adding an electron. The electrons are negatively charged. So, in total, we're going to get 24 valence electrons. This is going to be our total for this molecule. Now, what we're going to do, to find the number of lone pairs, we do 24 minus, we have a few options, 8, 16, 24, 32, and the list goes on. So we have to choose the one that's going to produce the number that is the least, but is greater than 0, or 0. So in this case, this will be 24. So 24 minus 24 equals 0. So this is how many lone pairs we'll have in the center. So when we make our atom, or our molecule, we'll have 0 lone pairs, so we don't need to draw anything. And because nitrogen is in the second row of the periodic table, it's going to want to follow the octet rule. So the only way that it can is it can have 4 bonds. It has to have 4 bonds. So that means that we have 1 double bond and then 2 single bonds. Okay. And since they're resonance structures, we can move the double bond anywhere we want. But we'll just use this resonance, or we'll just use this version. Then we just put our remaining valence electrons. So for our singular bonded, we'll have 6. 6 plus 2 is 8, so we filled the octet. For this one, 6 plus 2 is 8, and so we filled the octet. And then for here, we'll only have 4. Well, 4 plus 4, which is 8, and we satisfied the octet. And then in total, we have 2, 4, 6, and 8. So we just satisfied the octet of nitrogen. So this here is the Lewis structure for nitrogen, or nitrate. Anyways, I hope you like this video, and goodbye.